Similar to a 4-quadrant graph, there are also 4 quadrants in the unit circle. Quadrant 1 in the top right corner, Quadrant 2 in the top left corner, Quadrant 3 in the bottom left corner, and Quadrant 4 in the bottom right hand corner. Notice that they go counterclockwise. We can also look at the signs of the coordinates in each quadrant. So in Quadrant 1, we have a positive x and a positive y coordinate. In Quadrant 2, we have a negative x and a positive y coordinate. In Quadrant 3, we have a negative x and a negative y coordinate. And in Quadrant 4, we have a positive x and a negative y coordinate. And recall that the cosine of theta equals x, and the sine of theta equals y. Therefore, if we know the sine of x where it's positive, we'll know where cosine is positive. So for example, x is positive in quadrants 1 and 4. So cosine is positive in quadrants 1 and 4. The x coordinates are negative in quadrants 2 and 3. So cosine is negative in quadrants 2 and 3. Now for the sine of theta, since it equals y, and we know that the y values are positive in quadrants 1 and 2, then we know that the sine of theta is positive in quadrants 1 and 2. And since the y values are negative in quadrants 4 and 3, we know that the sine is negative in quadrants 4 and 3. Now there's another way to evaluate the signs of the trig functions, and that is by going back to their original definitions. So recall that the sine of theta, we'll look at the angle in quadrant 1, equals opposite over hypotenuse. So positive y over 1. Well, positive y value over 1 is going to be a positive value. If we look at the cosine of an angle in quadrant 1, then we have the adjacent side, positive x, over the hypotenuse, 1. That will also be a positive value. Note that the hypotenuse is always positive, always. Let's look at quadrant 2. In quadrant 2, if we were to analyze an angle there, and we looked at the sine of theta, the sine of theta would be opposite value y over 1. So a positive y over 1 is positive. If we looked at the cosine of an angle in quadrant 2, then we'd have adjacent, which is negative x, over the hypotenuse 1. Negative x over 1 is going to be a negative value. And we can do this in all 4 quadrants. And not only can we do it for cosine and sine, we could also do it for the other trig functions, the tangent, the cotangent, the cosecant, and the secant. Let's look at a couple of them. Let's look at tangent. So the tangent in quadrant 1 is equal to opposite over adjacent. So if we're looking at an angle in quadrant 1, the opposite side is positive y over positive x. So the tangent is positive in quadrant 1. If we look at quadrant 2, the opposite side, positive y, over the adjacent side, negative x, a positive over a negative is a negative value. So the tangent is negative in quadrant 2. In quadrant 3, the opposite side would be negative y over the adjacent side, negative x. Now a negative divided by a negative is a positive. So the tangent is positive in quadrant 3. And finally in quadrant 4, if we look at a quadrant 4 angle, tangent of theta in quadrant 4, it would be opposite over adjacent, negative y over a positive x, and a negative number divided by a positive number is a negative number. So the tangent is negative in quadrant 4. So to summarize, the tangent is positive in quadrants 1 and 3 and negative in quadrants 2 and 4. You can carry on a similar analysis for all 6 trig functions. Here's a diagram doing what we just did. So for example, if we look at the tangent in quadrant 2, we can see that the tangent of an angle in quadrant 2 equals a positive y value over a negative x value because it's opposite over adjacent. And that's going to give us a negative value. If we again look at tangent in quadrant 3, the opposite side was negative y and the adjacent side was negative x. A negative divided by a negative is a positive. Notice that we're constantly looking at triangles when evaluating things. Remember, trigonometry, after all, is a study of triangles. So in going back to our previous diagram, we have 4 triangles, 1 triangle in each quadrant. We're often using a triangle in each quadrant to evaluate a trigonometric function. If you keep this in mind, it will make many things in trigonometry much easier. I recommend pausing on this screen and studying each of the 6 trigonometric functions in each of the 4 quadrants, and do a similar analysis as we did with tangent until you can comfortably derive the sign for each function in each quadrant. It may help to visualize the triangles from the previous slide, here, in order to help you in your analysis.